Alright, that's the you guys might have to either be very careful here. I'm not really happy with the angle here corner, but let's get to work, guys. Are you able to see that? Hey guys, hey go. Please just ask them to take it down. Sure. Yes, I would suggest to go to Nhlaleni somewhere else. Angithembi. It's contrast. All right, let's get to work, guys. Let's get to work. There's just something I'm not getting right today. How Gandhi, what's happening? All right, may we please all settle down? I almost forgot my Huh? Oh, okay, I thought you were calling me. For some reason, I'm not really happy with the angle, Namhlanjas. I don't know, I just couldn't get it right here, but it is what it is. All right, good morning to those of you that are joining us from our channel. It is a pleasure for you to join us. Today we are looking at acids and bases. I'm sure that this is one section that most of you do anticipate and look forward to. Okay, Sibonga? Okay. All right. My point, you see. I don't know what, can I just check here the angle? Yeah? It's not that bad, but it's not good either. Let's go. Better. Okay. Yeah, so what I was saying is that, apologies there. So my point is that we are still busy with acids and bases, né, guys? And for those of you that are also watching, we are on the section here, acids and bases. Today, I'm going to try to stretch your thinking quite a bit. Is that okay? All right? So what we've done now, we've done questions on back titration. We've done questions on pH, We know how to calculate the pH for an acid medium. We know how to calculate the pH for an acid for a basic medium, right? Okay. We know how to apply the ionization constant of water. So, I think we are ready. What do you say? What do you say? So firstly, I want us to look at the question that I asked you guys yesterday. I said you must calculate the pH of a resulting solution, right? Hebana. Right? Mm-hmm. Our online people, that's what I said yesterday. Huh? Mary Jane. Morning. I did say we should look at calculating the pH of a resulting solution, right?
I've got disconnected somehow and I couldn't connect it.
Nkosi. Huh? Hi, yes, Gumnande, South Africa. Okay, Lisedi, let's ask you. That's what we said yesterday, right? Balele. All right. So I want us to start there, and really, guys, because it is something that is quite important. It's one of those scenarios where we are looking at a resulting solution. That is, if we either over titrate a solution or under titrate a solution. So what happens is that we try to neutralize the acid, or rather you would try to neutralize the solution of either an acid or a base, right? But if we find that the substance that we're trying to use to neutralize it with is insufficient or in oversupply, then we end up with a resulting solution, right? So we did such a question, Izolo. Question 5, we did it together. Today I want us to look at to question 6. Right, so they say to us, we've got a student that titrates 25 cubic centimeters of a 0.2 moles per cubic decimeter, 0.2 moles per cubic decimeter nitric acid solution, right, with 20 cubic centimeters of 0.1 mole per cubic decimeter sodium hydroxide. So what is our reaction here? Which are the two things that we are reacting together? That's nitric acid with sodium hydroxide. Remember, I said it's important for us to always find out how they react with one another, né? Right? So we say sodium hydroxide and nitric acid, what do they give us? They will give us sodium nitrate, that's our salt, but it also gives us H2O. Now, may I please find out, is this reaction balanced? Is it balanced? Is it balanced?
Yes, it is.
Okay. The answer to that is yes. It is balanced. Ne? Now, what does this tell us? It tells us that for every 1 mole of nitric acid, I will get 1 mole, or rather, I will use 1 mole of sodium hydroxide. Very important, right? So that's how they react with each other. So they say to us, this student titrates 25 cubic centimeters of a 0.2 nitric acid solution, right? So my first question would be, what would be the number of moles of nitric acid? So I'll say number of moles, that's concentration times the volume, right? What is our concentration? 0.2. And what is our volume? Our volume is 25 cubic centimeters, but remember, what must we do? We must convert it to cubic decimeters, isn't it? Okay, so this is going to be 25 divided by 1,000. That gives us 0.025. So, what do we get? 0.005? Confirm. Yeah, 0.005 moles, nah? Right, which moles are these? These are the moles for nitric acid. Why am I doing this? Remember, at the end of the day, I'm trying to find out which of these two are in excess, because whichever one is in excess will therefore determine the pH of our resulting solution. Are you guys with me, nah? Right. So, I've found out the number of moles for nitric acid. Now, let's do the same for sodium hydroxide. So, for sodium hydroxide, again, number of moles is concentration times the volume. So, in this case, that would be 0.1, that's our concentration, multiplied by 20 divided by 1,000, that gives me 0.02. And what does that give us? 0.002 moles. All right. Now, according to the reaction that we have there, right? For every 1 mole of sodium hydroxide I use, I will require 1 mole of nitric acid. Do you guys agree? Mm-hmm. Right. My question is, with the 2 that I have there, which one is our limiting reagent? Which one is the limiting reagent? Is it sodium hydroxide or nitric acid, and why? Which one is the limiting reagent? Huh? Nitric acid, is that what you say? Okay. So when you look at it, nitric acid is 0.005. The other one is 0.002. Right? And we know that they have a 1-to-1 ratio with each other. Meaning, for every 1 mole of sodium hydroxide, I need 1 mole of nitric acid. Right? Meaning, in this case, which one is more than the other? Right? That's definitely nitric acid. Do you guys agree, ne? So, in this case, by the way, this only will work because it's a 1-to-1 ratio. What you would need to do is go to your reaction and check how much of the one do you need to react with the other. So if, for instance, I assume that sodium hydroxide is going to be 0.02, I'll say, well, for 1 mole of sodium hydroxide, I require 1 mole of nitric acid. Okay? So if I use 0.002 of sodium hydroxide, how many moles do I require of nitric acid? If you cross multiply there, n multiplied by 1, that's n. 0.02 times 1 will give me 0.02 moles. So what does this mean? It means that the amount of nitric acid that I require to react completely with the sodium hydroxide is only 0.002 moles. Right? So how much do I have in excess? So which means I will say number of moles in excess will be the initial number of moles minus the ones that react. So the reacted number of moles. Are you guys still following, ne? Right. So I'm looking at nitric acid and I realize that's in excess, but by how much is it in excess? It's in excess in this case by, I started with 0.005 moles and only 0.002 will react. So it is in excess by 0.003 moles. Does that make sense? All right, so noted. May I ask a question? Is my resulting solution going to be acidic or basic? It's going to be acidic, right? Why? Why is it going to be acidic?
Because your acid doesn't fully get
Neutralized. Yes, yes, absolutely. Because my acid doesn't get fully neutralized, right? What happened is that I had a base, but our base was in short supply. All of that base, because it was a limiting reagent, is going to fully react with some of the acid. But as I now discover, I realize that, okay, I will have some of the acid that still remains unreacted. Are you guys with me so far?
Yes.
Okay? Right. Now, we want to look at this and say, we wanted to find the concentration, or rather, we want to find the pH of the resulting solution. Lebi, you had a question?
But like, I wanted to for you to re-explain why we chose the 0.002 instead of the 0.005. Is it because of the volume?
Ah, okay. Ogoti, why is it that we said the one is the limiting reagent and not the other? What is that the question? Okay. Why did we choose sodium hydroxide instead of nitric acid? Is that what you're asking? Okay. All right. So this is let me paint a picture. All right. I know that an acid reacts completely with the base, right? Or rather, is able to neutralize with the base. Okay? According to this reaction, it tells me for every amount of acid, 1 nitric acid, I need 1 sodium hydroxide. Meaning, for any amount of nitric acid that I have, I will require the same amount for sodium hydroxide if they are to fully neutralize. Okay? So I want you to think of it this way. If I had 5 molecules of sodium hydroxide, okay, that I need to squash, I am going to need acid to squash these guys, right? Now, if I had 5 of these, how many of the acids am I going to need, right? I'm going to need 5. So for every single one of them, it will need its own acid. Do you agree with me, no? In order for us to squash them. Okay? Now, as we would have it in this reaction, and I'm just making an example, I know it's 0.00, right? I found out that for the acid I've got 5, and I found out that for the base I've got 2. So, which means, how many of the base am I going to be able to squash? Only 2 of them. Can you see? I'll still have 3 molecules, in a sense, right, of the acid that are still left. Does that make sense, no? Right. And the only thing that dictated why, in this case, we took that is because we know that for this reaction, it is a 1-to-1 reaction. Okay? What does that mean? For every 1, I need 1. Okay? Meaning, for every 0.02, I need 0.02. But how many am I given? 0.005. Okay? Which means they gave me more than what I require to neutralize the sodium hydroxide. Does that make sense? Okay. So then I said to myself, but then how many moles of of nitric acid will remain unneutralized? Right? And remember, the ones that remain unneutralized are the ones that are going to determine the pH of the solution. Right? If all of them had neutralized completely, the pH of my solution would have remained at 7. Because you're taking A strong acid together with a strong base. Are you with me now? So if we're going to test here at the end point, we're going to find that our pH plays around 7. It's neutral, right? But in this case, because I've got excess acid, right, it means that my resulting solution as a result is actually acidic. Make sense? Okay. So what I did then is to say, look, let's find out how many moles of the acid are therefore in excess. And if they're in excess, it means now they are going to actually, they are going to determine the pH of our solution. Okay. So we found out Tubuti that's 0.003 moles that are in excess. So this is nitric acid moles. We used 0.002. We are left with 0.003. What's that sound? Huh? Okay. All right. Are there any questions? Our online people, are there any questions?
No, sir.
All right. Beautiful stuff. So we are looking for the pH of the solution. So you remember yesterday, Sitegonyo, what do we need for the pH of the solution? To calculate pH. I need the concentration of my hydronium ions, right? Now let's start with just the concentration of nitric acid in this case. So concentration would be number of moles divided by volume, right? Now remember when I painted the scenario yesterday? Here it is. You had nitric acid, okay? Let's say HNO3, and you have sodium hydroxide. And what am I going to do? I am going to add these two together, right? Let's say we've got some molecules of nitric acid. Now, what we realized is that we had more number of moles. Let me make a nitric acid in red. Right. Do you agree with me? You've got fewer molecules of sodium hydroxide. No? So what's going to happen? When you add these two together, you will now get a resulting solution. Now, imagine if the red particles and the blue particles, when they react together, they give us an invisible particle. Okay? What's going to happen? Because I've got more blue than red, now I add these two together, right? So here's my resulting solution. Because I've got more blue than red, all of the reds will be squashed out. What am I going to end up with? A solution with blues only, right? And there are fewer blues than there were initially. Why? Because they've been squashed by the red particles. Make sense? Mm-hmm. Right. Now, in this case, what I'm trying to do is to find out what is the concentration of this resulting solution. So how many particles of the blue am I left with? Well, we found out we are left with 0.03, right? After the reaction has taken place. What is the volume of my resulting solution? Right. So remember that volumes are additive, which means we add the one volume to the other. Are you guys with me now? Right. So which means, Gonjo, what was the volume of the two? That's 25 cubic centimeters for nitric. That's 20 for the... So that's 25 cubic centimeters here. That's 20 cubic centimeters for this guy, which means my resulting solution should have 45 cubic centimeters, right? When we add the two. So please calculate the concentration for me. Say that again. 0.07. Okay. So we said number of moles is 0.03 divided by the volume. That's 0.45 divided by 1,000. Ne? So that's 0.045. You said that gives us 0.07. Rounded off to 2. Okay? 0.07. If it's not rounded off? 6 recurring. Okay, 0.666. Okay. Right, if you don't mind, let me just write it as 67 for now. Moles per cubic decimeters. All right, guys. What is this concentration?
Nitric acid.
It is the concentration of nitric acid. Okay? Right. The resulting solution. So now, am I ready to calculate pH?
No.
We're not. Ne? What do we need to calculate pH? Hydronium ions, right? I need to find out what is the concentration of our hydronium ions. So firstly, I need to find out how does nitric acid ionize in solution. So nitric acid comes H plus and NO3 minus. What does this mean? For every 1 mole of nitric acid, we get 1 mole of hydronium ions. Make sense, guys? Right. So therefore, it means the concentration of nitric acid will be equal to the concentration of our hydronium ions. And so that would be 0.067 moles per cubic decimeters. Are we all good so far? All right. Can we calculate pH now? Yes, we can. Right? So, that's minus the log of our H plus concentration, which is negative the log of 0.067. Okay, and
1.17.
point, yeah, 1. 1.17, and that's the pH of our resulting solution. Okay. Please tell me that it made sense. It did? Small, small. Big, big. Big, big. Okay. All right. I'm more than happy to go back if there's still a part that you want to write. Is it right? All right. So, yebo. Negative log, yes, that's base 10. But remember, Guti, when you say negative log, it automatically, unless you've got a different base other than 10, it's negative log base 10 of whatever. But if I just say log of a number, it assumes that the base is 10. Okay. Right. Happy? Is it right now? Okay. Right. So, here's what I'd like for us to do just a bit here for today. I want us to look at a scenario where we're given pH, right? And we want to find out. So let's say, for instance, a solution of, let's say, sulfuric acid, H2SO4, okay? is prepared by dissolving X grams of anhydrous All right, so we will have instances where we will have to determine, all right, maybe either the concentration, or we'll have to calculate the number of moles, or whatever the case may be, given this time pH. So if we are given pH, how do we work around this in reverse? Okay? So the question says a solution of sulfuric acid is prepared by dissolving X grams of anhydrous. Now, I'm just hoying these terms so that I sound fancy, ne? No, the reason why I'm giving these terms so that you know what they mean, okay? So when you say that something is anhydrous, it means it's in powder form, okay? So anhydrous, you get something that's in powder form, and what you do is that we are going to dissolve it with water so that we make a solution. Okay? Right. They say that the pH of that solution is 2.3. All right? So, of course, let's calculate the mass. Right. So I want us to determine the mass of the anhydrous sulfuric acid that we added. Okay? So, if you don't mind, if you can just stop writing for now so that I can explain the scenario to you. So usually, we know how to work with given concentration of our hydronium ions. We know how to find out what the pH is, right? The question is, how do I now find the pH, or rather, how do I find the concentration of the hydronium ions given the pH, right? So remember, guys, I want you to always remember that you need to write down the formula first as it appears, okay? That's where we get some of our marks. So pH is going to be minus the log of H3O plus. And I did say yesterday that you can use H plus and H3O plus interchangeably because it's the same thing, right? I showed you why it's the same thing. So pH is equal to minus the log of H3O plus. So what can we do now? We know what pH is, that's 2.3. That's minus the log of hydronium ion concentration. Now, without us getting too involved in the maths, okay? Right, I could show you in this case how we just simply convert from logarithms to exponents, right? So just remember, what we are going to do is say H3O plus concentration. You take the base, okay? So the base of our log is 10. This is exponent minus pH, okay? So it's always 10 to the minus pH, okay? So that's 10 to the power minus 2.3, Right, and so what would be the concentration of our hydronium ions? I get 0.005. Okay, so that would be 0.005, ne? Very quickly, here's what I want you guys to do. Find out the mass of the sulfuric acid that we added. Right, for those of you that are also watching this, please could you try out the questions on your own? And if you happen to get the answer before we do, can you please just put it on the comment section? I think the thing that I'm just trying to show guys is that acids and bases more stoichiometry than, there's a little part here, acids and base, and it just goes back to being stoichiometry, nah? Should I count you down? Because I mustn't complain. Okay, I'll just come here to check. Very important. Okay, I'll come back. Oh, yeah, but on this one, yeah. The formula I see is N over V. And Marino. Yeah. So, what do we need to consider? How?
So it's like this should be so because not the exact same, you have to
What do you buy?
That's how you break it.
How does it
Then times 2, that get the moles of this guy. So this guy now,
Yeah. Sorry.
yeah. So the moles is oh no, we don't have to be times 2, it's actually the same.
Great concept.
It's this, I can do this.
Right?
Also do this.
It's better you to cover the system.
Actually, let me check.
And now what we have? We have this. we're trying to get this. Oh, okay. Not for any pressure. Okay, I should be saying no pressure. No? Okay. Before you continue, because I wanted to see how you guys would continue. No? So before you continue, please remember, which acid are we looking at? Sulfuric acid. How does sulfuric acid act? What type of acid is it? Yes, it is a strong acid, but it's also, remember, H2, so it means it's diphothic. Right? So which means for every one sulfuric acid, I will always get two hydrogen ions. That's it.
Like this.
Yes, that's the one. That's the one.
Isn't it because we're doing it like with this one? It's one. One is one. No.
So remember, Anitya, this is where we are. You've just found out the concentration of hydrogen ions, right? H2SO4 becomes 2H plus SO4 2 minus. We is here. We've just found the concentration of these, right? Where are we trying to go? We're trying to go over here. Because we're looking for the mass of sulfuric acid. Okay. So if we have this, what would be the concentration of sulfuric acid? So remember, for everyone there's 2, and you've got this guy. How many will you have sulfuric acid? I don't know if I have acids. So you understand why she took that everyone something was yes, I know that but remember, if it's too electrical, it means you end up with sulfuric acid, having given H plus, right? So this is the next so meaning for every one of us, remember, everyone gets that. Now you got this. So this simply says, for every one person, there's 2 atoms. Right? So if I've got 16 atoms, how many people? So we said for 1 mole of sulfuric acid, we get 2 of those, right? So now, how do we get the concentration of sulfuric acid? So can we get it first? 1H2SO4, we are going to get 2H+. How many, what will be the concentration of this one? If Meaning, I'll divide that.
I think that's what we are.
You get it? What are we assuming? We are assuming complete ionization. Right? And if it's complete ionization, then it means that sulfuric acid would have given off all of its right. Awesome stuff. All right, I'll be with you just now. I want to see that one. But why Yes. So to get the concentration in sulfuric acid, once you've got the concentration, you can get this. Okay. All right, let's get to it, guys. So please don't forget, guys. So whenever we look at these kind of questions, what is our underlying assumption? We assume that we have complete ionization, right? So which means that sulfuric acid is going to ionize completely. All right? So let's quickly have a look at it. So I'm now going to say, right, I've got the concentration of the hydronium ions, but how does sulfuric acid ionize? We said H2SO4. What type of acid is it? It's a diprotic acid, right? So it will give me 2H plus SO4 2 minus, which means, very important, for every 1 mole of sulfuric acid, let me just do that in a different color so that, see, emphasize. For every 1 mole of sulfuric acid, I am going to have 2 hydronium ions. Make sense? What type of acid is sulfuric acid? Yeah, it tastes strong, Mara. It's also diprotic. And we are assuming complete ionization, right? So meaning it would have given all of its hydronium ions away. Are you guys with me, nah? So that's why we are going to use this reaction instead. So we're saying for every 1 sulfuric acid, I get 2 hydronium ions. Remember I said to you H plus, H3O plus, exactly the same thing. Nah? So the question is, how many moles? I'm going to make it X. Or what is the concentration of sulfuric acid if the concentration of hydronium ions, that's what we found here, right? If that concentration is 0.05. And so what we do is to cross multiply. So we take 2 multiplied by X, that will give me 2X. 1 multiplied by 0.05 will give me 0.05. And if I divide both sides by 2, X will give me 0.025 moles per cubic decimeters. Now, what is X? We said X is the concentration of sulfuric acid. Over to Sasanam. 100%. Okay. What am I trying to say, guys? I made an example right now, when I was just moving around checking your progress. I said to you, so imagine I said to you, for every one person, and it's true, né? Of course, assuming everything is, as it should be. For every one person, there's 2 eyes. Okay? That's what we know, right? Okay. So for every one person, there's 2 eyes, right? Except for people like Gia. Okay. Yeah, but now shy double everything, not double. Oh. Okay. Good one. Okay. Right. So for every one person, there's 2 eyes. But if I gave you the number of eyes, how do you get the number of people? So if I said to you, there are 16 eyes that are looking at me, right? How many people are there?
8.
There's 8 people, right? So that's exactly what we did. We now had the number of eyes. We said for every 1 sulfuric acid, it will give us 2 of those H pluses. But now what did we have? The number of H pluses. And we want to find out the amount of sulfuric acid. Does that make sense? So meaning it will be half what I have. So a half of 0.025, that's why we got the concentration. And please note, X is the concentration of sulfuric acid. But what were we looking for? The mass, right? We're looking for the mass of sulfuric acid. So there's a formula that says concentration is mass over molar mass multiplied by volume. Otherwise, you would have had to calculate number of moles first, right? And then calculate the mass. Né? I prefer this. So whenever you've got concentration and you are looking for the mass, or if you've got mass and you're looking for concentration, this is definitely the formula to use. Okay, right. Concentration, 0.0025. What are we looking for? The mass. Then we go to the periodic table and check. What is the molar mass of sulfuric acid? 2 hydrogens, so that's 2 times 1. Sulfur is 32, right? Plus 4 oxygens, so that's 4 times 16. And what does that give us? That's 98 grams per mole, right? So I know big M in this case is 98. But what about the volume? We're already given the volume to be 200 cubic centimeters. So we need to be careful, right? So we need to convert that to cubic decimeters by dividing that by 1,000. So 200 divided by 1,000 gives us 0.2. And so all we do is cross multiply. M times 1, that's M. And we've got 0.00, yeah? Is it 0.00 or 0.0?
0.00.
Okay, 0.0025 times 98 times 0.2, and I end up with a mass. Is that correct? Is that what you guys got? Okay. Oh, okay. Okay, so I get 0.049 grams. Okay, right. So this is the amount of sodium, no, not sodium, sulfuric acid that I would have added. Is goodies nice? All right. Can we stretch ourselves a little bit? Okay. Well, I didn't mean literally, but okay, that still works. That still works. Okay. So, how would this scenario change if I were to give you the concentration, or rather, if I were to give you a base, right? So let's say an unknown amount of, let's say an unknown mass, let's be specific. Unknown mass of, just near for variation, of potassium hydroxide right, is dissolved into 0.45 cubic decimeters of water. The pH of this solution right. So we've got an unknown amount of potassium hydroxide that is dissolved into 0.45 cubic decimeters of water. Right, the pH of this solution is 12.1. So what I'd like for you to do for me is to find out what the mass of potassium hydroxide is. Do I need to specify? Assume temperature to be 25 degrees Celsius. That's my hint. Right, it would be nice to see your comments as well for those of you that are on our channel. The people online, Nisase right mar.
Yes, sir.
All right, school is nice. Okay, can I just check? Where do we start with this one? Yeah. From concentration. Is there something about concentration? Yes? Huh? Say that again? Yes. Concentration of your hydronium ion. So you can either go the pOH route. You remember we did that yesterday, no? Or we can go the route of the ionization constant of water, right? Okay, so please try to catch up today on yesterday's lesson. Okay, so we looked at the ionization constant of water. I'm throwing some hints. We'd have to go through here. Or, remember we said pH plus pOH is equal to 14, right? If you get that mess, say, I have it. I'll be with you just now. somehow it landed you back into the same zone.
No.
It's really unnecessary. You'd rather just calculate if it's okay. Yeah, we'd rather just calculate and just give.
Oh.
Yes, but you see, very easy to recognize that. So you need to then explain. No. What I'm trying to tell you is that you can use those formulas. Remember, what is all that constant is only applicable at 25 degrees. And that's a very, very good question. So remember, still for basis. Don't even look at it. So this is how they dissociate. That's the way it right? So now, instead of hydronium ion cis-12, so now, remember, whereas large from pH, you got the concentration of hydronium, right? So how do you relate the two? That's this comes in.
After the integrated question, they use that to get KOH.
All right, guys, in relation to the 25 degrees, remember, Uti, this is all related to that formula that I've given to you. Right? Remember, the ionization constant of water is 1 times 10 to the power negative 14 at 25 degrees. Okay, if they've said nothing about it, you assume it's 25 degrees, but most of the time they will specify that this is a 25 degrees. Right? Now, everyone just one. Concentration.
No, what is the equation?
For what? This is KOH. So that's how it's good. All right, beautiful stuff. Okay, it's encouraging to know that at least we know what to do when we are given a base. Né? All right? There's that conference that's taking place there. No, not that I mind. Not that I mind. Was it a helpful conference? G20. Huh? It's a women's conference. Okay. All right. So, the difference this time around is that we're given the pH of a base, right? And remember that a base does not give us hydronium ions, isn't it? So we'll need to pass by somewhere first before we can determine the mass of potassium hydroxide. So, firstly, so we're given the pH, so we know pH formula. And guys, the pH formula does not change. So simply because we're given the pH, it means that now we should be in a position to find out what the concentration of our hydronium ions is. Is. Hydronium ions okay. Okay, so remember that's 10 to the power negative pH. Please don't forget to put that negative there. But we already know what our pH is. Our pH was 12.1, isn't it? Right, and so what did you get for the concentration of your hydroxide ions? Okay, 0.01. 0.01. And remember, this is concentration, right? Now the question is, what does hydronium ions, or how do they relate with hydroxide ions? Because definitely those hydronium ions don't come from potassium hydroxide. Okay, so in order for me to find out what is the concentration of potassium hydroxide, I need to find out what is the concentration of my hydroxide ions. So this is where we knew, okay, so remember the ionization constant of water at 25 degrees would be H3O plus multiplied by hydroxide ions, and this is equal to 1 times 10 to the power negative 14. I'll show you the other way we could approach this question. So this is 1 times 10 to the power negative 14. But what do we have? We've got the concentration of hydronium ions, hydronium, multiplied by concentration of hydroxide, and this is 1 times 10 to the power negative 14. So we can now divide both sides by 0.01. It's good, it's nice? It's good? All right. So, what was the concentration of our hydroxide ions? Say that again.
It was 1 times 10 to the power
1 times 10 to the power negative 12. Ne? Okay, 1 times 10 to the power negative 12. And because this is concentration, that's in moles per cubic decimeters. What did we just find? Okay. Oh, Shem, sorry. Sibonga, can you just please switch off the aircon there? Ngizwa abantu sebasneeza. Hopefully they didn't catch something. Hey, do me aircon usuke efonini man. Oh, yini calculator. Cine aircon. How? Okay, so hydroxide ion concentration. That's 1 times 10 to the power negative 12, right? So what do we now, how can we find out what is our mass of potassium hydroxide? So we're going to say, but how are hydroxide ions manufactured, right? Well, they come from potassium hydroxide. When it dissociates, it will form potassium ion plus hydroxide ion. Now, in this case, what do you notice? For every one of this, I will get one of that. Why is that important? Because Mobile, you're saying something. Because, why is that 1-to-1 important? Because we already have hydroxide ions, isn't it? What are we trying to find? The concentration of potassium hydroxide. Now, if for every 1 there's 1, which means for 100 there'll be 100. It means for 1 times 10 to the power negative 12, there will be the same number, isn't it? So therefore, I can say the concentration of potassium hydroxide, without the minus, right, the concentration of potassium hydroxide will be equal to the concentration of hydroxide ions, which is 1 times 10 to the power minus 12. Why? Because it is a 1-to-1 ratio. Are we together, guys? Me right? Why not yan kwatisa nje acids and base? Huh? Ukwatil? You look confused. Your face says yes. Yeah. Scroll back up.
It's the same thing.
No.
Huh?
With the 7 commenting, I just confirmed it.
Yeah, man. What are we not minding, man?
What we got?
No. No, 10 times 10 to the minus 12.1.
No.
Yeah, no. It won't be the same thing. Yeah, you know what? I see what you're complaining about. Yes, please give me the correct answer too. Yeah, I think this is when you went the POH route. Correct? Lorraine, I'm asking you.
POH?
Yeah. Yeah, I think that 0.01 is if you are looking.
I got 7.94
94
Then I went to compare.
Mind you, why were you guys quiet?
No, but I see. I'm gonna get the same answer. For which
Yeah, but you know, 0.01. And, you know, guys, okay.
7.94 times 10.
7.94. So you're sitting all this time just.
No, because I was doing the other version. Times 10 to the negative 13.
Times 10 to the power negative 13. That's moles per cubic decimeters.
Yes.
Hi guys, come on now. All right, so which means this changes 7.94 times 10. Hey, yeah, ne? Ha. Yes, I'm just thinking of a scenario where someone you let someone get lost, right? you literally watch them getting lost, and then Maselabu and say, hey, I couldn't find. Oh, you know, but I saw you going the other way. Why didn't you say?
You feel like I would compare and check as in like how did that, but then we
Is that what the conference was about? At the back there. Hi guys. Yeah.
So you see that 7.94 Is it okay if we leave it at 2 decimal places? Because in that other example, the previous one, I
Yeah.
used 2 decimal places and I got a different answer.
You got a different answer.
Then when you guys left it at 4, it was the same answer. So which is which?
Which is which? Which is the I think it would be great if you can keep the answer as is, but I suppose if you converted it to 2 decimal places, there's no qualms there. Okay, yeah, but I think even if we get the answer, it's not going to be too different, right? Yeah, it's not going to be too different. I assume that there's something that kind of went wrong. I don't know. Okay, so please help me out again. What did we get? 7.94 times 10 to the power minus 13. This is where the 0.01 comes from, ne? All right. So meaning the concentration of hydroxide would now be 0.01 moles per cubic decimeters. Good? Good? Okay. Good? Are you still complaining? No. Okay. All right. So we've got 1:1. Correct?
Yes.
All right. Okay. Hi, man, guys. Hi. So we've got 0.01. So that would be the concentration of our hydroxide ions, right? But we knew that this is the same as the concentration of potassium hydroxide because of the 1:1 ratio. Now we can use concentration as mass divided by molar mass times volume. Our mass, this is what we're looking for, but our concentration is 0.01. Potassium hydroxide, from the periodic table, potassium is 39, oxygen 16, hydrogen is 1, and the volume that we were given is 0.45, right? So in that case, we've got 0.45 cubic decimeters. Right, eventually what did you find for for the mass? 0.25. Okay.
0.25. And then when you use the full answer, you're getting 0.3 something.
3.2.
So 3.2, exactly.
Yeah, okay.
Yes.
That's because you rounded off to 0.01. That's
I
what the
didn't use
issue.
0.01. I said 0.01.
No,
1, 2.
I said this answer comes from the 0.01. If it was 0.0, like 1.3, we get 0.33.
3.2. Yeah.
But if you go 0.0125, you'll get the 0.32.
Okay. So our answer is between 0.25, okay, to 0.33, depending on how you round it off. All right. Is that good?
Yeah.
All right. Okay. Okay. Anyone else who's got a complaint? Huh? Yeah, you still look not too grumpy. What's up? Huh? But you didn't get the answer.
Yeah, I've got sugar things.
Is it? Oh, okay. Interesting. In that range. So in that range means utolem 0.28,
0.32.
0.32. Okay. All right. We're still within there. Anyone else? Okay. Right. Okay, guys. We'll leave it there. Ne? And so what I was just trying to do today, just need to bring it back. So there are instances where we will be given the pH of a solution, right? And we'll have to work our way backwards. Now, not only that, I want you now to start imagining this scenario. I want you to imagine that I had given you the pH of a resulting solution. You remember in our initial question, right? We mixed acid and base. We're trying to neutralize them together. But then we found out one of them was in excess, right? And then what that eventually gave us was the pH of the resulting solution. I want you to think of that in reverse, and that's what we're going to be doing next. Okay, where we've got the pH of a resulting solution, and we know we mixed acid and base, but we didn't know maybe the mass of one of them. Okay, so we are trying to work our way backwards. All right, awesome stuff. I'm going to give you guys a worksheet. Please work through it. Okay, very important. Please make sure that you complete all the questions that I'm going to give you guys. Nah? All right. It's good. It's nice. For those that are joining us from our channel, Chovito, I hope this was helpful. And also for those of you that are joining us online. Hey guys, I almost forgot about you. Yes. All right, I almost forgot about you. All right. I'll see you guys again tomorrow. All right, and please complete all the questions that I'm going to give in that worksheet. Shop, shop. Yo, I didn't know you guys can fight so much for 0.0.
You get in trouble when you don't do the right thing.
Goodness. Oh. Hey, someone was ready to roll up their sleeves and go sharp and okay.
The amount of marks I've lost because I've like rounded off in the wrong place.
Is it?
Before, yes.
So that's very important.